So in the previous video, we saw how to implement stack and queues using deck data structure in Python. So in this video, we will learn about tree data structure. So a tree is a non-linear, very much important, a non-linear data structure because till now we have seen data structures like array, which is a linear data structure. We have seen stack, we have seen queues. These all are linear data structures. But a tree is a non-linear hierarchical data structure that consists of nodes which are connected by the edges. So all these circles here are nothing but nodes and they are connected by the edges. So a node is nothing but an entity that contains a value and pointer to its child node. So if we consider this node A, so this node A will have its own value. Let's say it has a value 4 and it will contain two pointers which will point to the address of its child node. So it will have two pointers. One pointer will point to the address of node B and one pointer will point to the address of node C. So this is basically a node and the last node of each path are called leaf nodes. So if you consider this path A, B, D, I, so I will be the leaf node as it has no more further childs, and the topmost node of a tree is called a root node or a parent node. Now moving forward, we have some properties of tree. The first property is that there should not be any cycle in a tree. So suppose we have this tree. This is the root node of the tree and these are all the childs of the root node. So this is not allowed in a tree as a cycle is formed. And now this we have second property that all the nodes of the tree are always connected. So suppose we have a tree. So it should not happen that this node is not at all connected to the tree and this is not allowed in a tree. So now the next property is if the trees have n nodes, then it will always have n minus 1 edges. So this is very self-explanatory. As we can see here, this tree has 5 nodes and 4 edges. So these were some properties of tree. Now moving forward, we have binary tree. So a binary tree is a tree data structure in which each parent node can have at most two children. So till now we have seen trees in which a parent node can have as many children as possible. So in this case, this is our parent node and it has three children, and these children may also have their further children. So, but this is not the case in binary tree because for a binary tree, it is mandatory that every parent node can have at most two children. So in this case, we can see this node 1 have two children, 2 and 3. This node 2 have two children, 4 and 5. Similarly, 3 have 6 and 7. So this was a binary tree in a nutshell. But and also there are three important properties of the node in a binary tree. So suppose we consider this node 1. So this node 1 will contain three major components. The first will be the data item, where that is the value of that node itself. So suppose it has a value 5, and the second one is address of left child, so it will also contain address of the left child, and the third one is address of the right child. So these are the very important components that each node in the binary tree will contain. Okay, now let's implement binary tree in Python. For that, I will create a class node. In that, I will create a constructor and I will pass a parameter val in it. Now I will create a data member, class member called data, and pass the value val in it. I will also create a left which will be none initially, and a right which will also be none. Okay, so now what I will do is create a class, create an object of this class. Okay, so I have created an object called root of class node and passed parameter 5 in it. So as I told you, a node in a binary tree has three major components. First is that a node will have its own value. So here we pass the node value as 5, and it will have address of its left child, which will be none initially because right now it has no child, and address of right child will also be none because we don't have any child of this node. So now what I will do is I will write root dot left equals to, and I will again create a node. So what will happen is root dot left will get the address of this node, and here a new node is created, and that node is assigned as left child of this node. And so I can also create a right child for this, say node 7. So now what will happen is let me draw this tree. So now our tree looks like this is our parent node with value 5 in it, and we have left child. Let me see who is the left child. Okay, so here 6 is the left child, node with value 6, and node with value 7 is our right child. And this, the left child of node 6 will be none, and so will be right child. Same with 7. So this is what our binary tree looks like, because node 6 and if we want to assign children to node 6, we can also do that. So we just have to say root dot left dot left, let's say 8. We can also assign right child to node 6. Let's say we assign 9. So now our binary tree will look like, this. And again, this will be none, and this will also be none. So now let me tell you what happens if I print this root node. So when I print root node and run it, you can see it has given me the address of the root node. But what if I want to print the value at that node? So you will just say root dot data, and when you run, as you can see, the value of that root node is printed, and we assigned 5 to it, so we got an output 5. Similarly, you can do this with the child nodes. Let's say you want to print the data for left child. You can see it gave us output at 6, and this was our binary tree. The left child was a node with value 6, and if you want to print the address of the left child, you can just say, so it will give us the address of the left child. See, it has given us the address. So this was all about a binary tree, and there are many other ways to print the binary tree. So print in the sense we traverse through the binary tree. So there are many ways like in order traversal, pre-order traversal. So we it is not required for phase 1. So we will see that if it is required, I will make video on that also. So in the next video, we will move on to graphs, which are extremely important for AI search algorithms. So make sure to check it out because graphs form the foundation of algorithms like BFS, DFS, A star, and many more. So that's it for today. See you in the next video.